Now, in the lottery problem, the first thing I have to understand is how many days are there in each month. That's important for option 2 and option 3. And I know that there are 28 days in February. So first one, again, I know it's a lump sum, so that's 1,500,000. The second one, I've got to pay a little bit more attention. First, they put $500,000 in my account, and they're going to add $36,000 every day of the month. That means on day 1, I have $536,000 because they added the 500 to start with and the 36,000 for that day. On day 2, I would end up with 572,000. And I can see then what's happening is every single time I'm adding 36,000, which tells me I have an arithmetic sequence. And that, if I remember, is that I'm going to find the 28th entry, and that would be using my difference, 500, or the 36,000, times the n minus 1 plus my initial amount, my first day. And if I then replace that n right there and put 28, I know that I can then calculate, because I'm going to do 36,000 times 27 plus the 536,000, and I would end up with 1,508,000. So right now, option 2 is a better option than option 1. Now let's look at what happens in option 3. And I'm going from day 1 with a penny, and I double every day. So I go from a penny, then I have 2 pennies in the account, then I have 4 pennies in the account. That seems ridiculous. So what's going on here? Why would I even consider this option? So let's look at what happens. When I'm doing a doubling, I know that I'm really looking at the geometric sequence. So my R value is 2, and I know then that my first amount was a penny. So I can look at the geometric sequence of 28 days, and it would be my initial amount, 1 penny, times 2 raised to the 28 minus 1. And if I calculate this out, amazingly, and because I leave it with the decimal value of 0.01, that helps me keep it in dollars, and I don't have to worry about consideration of converting this from pennies back to dollars. I end up with $1,342,000, or $177.28. So that penny in 28 days turned into $1,300,000. That's crazy. However, let's see what happens when we increase our days. So I'm going to take this 28 days, and everywhere there's a 28, I'm going to replace it now with the number of days in March. So instead of being 28, we can now think, oh no, we're not dealing with 28 days. March is 31 days. So now we're looking at a 31-day month. Let's see what happens here. So we know we got 31 days. So here we're going to go to 31, and here 31, and here 31. And let's see what happens as we calculate this out. Now if I calculate out the first example here, where now look at my 31st entry, I end up with this becoming 1,616,000. We already knew this was better than option 1, but it becomes even that much better in the month of March. So we would love to win in March. Now let's see though what happens on the bottom one. If I take the same problem, 1 penny times 2 raised to the 30th power, that becomes 10,737,418.24. Now think about that. We just added 3 days. That's it. 3 days to this geometric sequence, and we've gone from $1.3 million to $10.7 million. And it shows you the power of the geometric sequence and what happens when we are multiplying from one value to the next, how quickly that can grow, especially as those numbers get large.